Here is a combined summary of the 2 pages. The proliferation of fake news on social media platforms has become a significant concern, with far-reaching consequences for individuals and society. The lack of comprehensive and community-based fake news datasets hinders research in this area, and existing datasets are often scarce, unverifiable, and limited to specific topics. Moreover, the high volume and speed of news generation on social media make it challenging to label news items as fake or real in a short period. To address these challenges, researchers have proposed various algorithmic approaches for detecting fake news, including content-based, network-based, and hybrid methods. Content-based methods focus on analyzing textual and visual features of online content, while network-based methods examine the social context and spread pattern of online content. Hybrid methods combine both content-based and network-based features to improve fake news detection. This paper proposes a semi-supervised self-learning method that incorporates sentiment encoding and LSTM with self-attention layers to detect fake news. The proposed method utilizes the Fake News Net dataset, which includes comprehensive information with diverse features in news content, spatial information, social context, and user page information. The self-learning semi-supervised deep learning network combines a trust network layer with an artificial neural network to detect fake news, leveraging the graph structure of social media data to capture semantic and relational features of news articles and users. The proposed algorithm employs a pseudo-labeling technique to reduce data loss and enhance reliable prediction. The workflow of the algorithm involves initializing the deep learning network with a small number of labeled samples, generating pseudolabels for unlabeled samples with confidence values, and filtering out low-confidence pseudolabels. The algorithm iteratively updates the trust network layer with new data, enabling it to adapt to new scenarios or domains. The advantages of the proposed approach include its ability to handle the scarcity and imbalance of labeled data, adapt to new scenarios or domains, and combine temporal dynamics and patterns of fake news dissemination using LSTM and attention mechanisms. The proposed method is expected to achieve higher performance and robustness in detecting fake news in social media. The semi-supervised self-learning algorithm proposed in this paper utilizes pseudo-labeling to address the issue of limited labeled data. The algorithm begins with an initialization phase, where the data is divided into 3 sections: training, evaluation, and test data. The training data is further divided into K folds, with labels only present in the first fold. The self-learning deep neural network model is fitted to the first fold's training data and evaluated using the fold's evaluation data. The model's trained weights are then used to predict the second fold's data, and a confidence threshold is set to retain labels with high confidence values. This process is repeated until all folds are pseudo-labeled. The proposed model architecture consists of 3 input features: textual data, numeric data, and date. The embedding layer receives news textual data and converts it into a dense vector representation. The LSTM with self-attention layer combines the advantages of LSTM and attention mechanisms to capture long-range dependencies and global information within a sequence. The self-attention layer computes a weighted sum of all states in a sequence, where the weights are learned based on the similarity between states. The fully connected dense layer applies a linear transformation followed by an activation function to produce the output. The paper also explores the use of transfer learning from sentiment analysis to detect fake news. Sentiment analysis features, such as polarity and intensity of emotions, can be useful for both tasks. The model can learn these features from a source domain or task and transfer them to the target domain or task, reducing the need for large quantities of labeled data and enhancing the model's generalization capability. The proposed method uses 2 pre-trained pipelines from Roberta to encode the news text and tweet text into nominal features of sentiment analysis. This sentiment encoding process helps the deep neural network in the semi-supervised self-learning model to label and identify fake news using text sentiment analysis. This research paper proposes a self-learning semi-supervised deep learning model for fake news detection using transfer learning of text sentiment analysis. The model utilizes a comprehensive dataset, Fake News Net, which includes features such as textual news content, tweets, responses, and sentiment. Due to Twitter's privacy policies, the dataset initially consists only of labels, news headlines, news sources, and tweet IDs, which were crawled and extracted using a Twitter API and a crawler extractor. The proposed model's architecture is based on a deep neural network with sentiment encoding, which incorporates features such as the title, text, source, and date of the news, as well as the text of the tweet, the number of retweets, and the user's Twitter registration date. The model's evaluation results show superior outcomes compared to previous methods, with an accuracy of 0.8619 and an F1 score of 0.8701. The paper also compares the proposed model's results with those of basic machine learning methods, such as logistic regression, naive Bayes, SVM, and random forest, as well as with those of semi-supervised models with various architectures. The results demonstrate the proposed model's effectiveness in solving the fake news detection problem. The paper highlights the challenges faced in collecting and preprocessing the dataset, including Twitter's suspension of user accounts, deletion of tweets, and limitation of access to user information. To overcome these limitations, the authors implemented a crawler to extract the dataset and applied modern preprocessing methods. The paper concludes by discussing the significance of the proposed method in solving the fake news detection problem, which is inherently semi-supervised in nature. The authors suggest future work directions, including adapting the confidence threshold variable, involving more models in sentiment encoding, and building upon previous work to create a more diverse and comprehensive dataset.